Hello everyone, welcome back to another lesson in division. I hope that you're finding that division is getting easier for you as you're using the strategies that you're learning in this unit, and that it's not the scary thing that most students see division as being. So in this unit, we're talking about estimation in division, and we will estimate quotients by rounding each number to the nearest 10 or 100. So remember our rounding lesson that we did before and how we round numbers up to or down to the nearest 10. Also remember that estimates are not exact answers. So we're not looking at the exact answer when we estimate. They are close to the exact answers. Only close, but not the exact answer. But even though we're not talking about exact answers, remember the closer an estimate is to the exact answer, the better the estimate is. So we want to get as close to the exact answer as we can, but it's okay if it's not exactly the right exact answer. So let's look at this one to start with. We have 160 divided by 20. How can we make this into an easier division statement? Yeah, this is what we learned last time, right? If we take off the zeros, what do we end up with? Cutting a 0 from all the numbers is the same thing as dividing them all by 10. So if we took 160 divided by 10, we'd end up with 16. 20 divided by 10 would be 2. So our answer there, that's much easier to figure out, right? 16 divided by 2 would be 8. If we cut 2 zeros off a number, that would be the same as dividing it by 100. So remember last time we just cut off 1 0 and said that that 0 in the dividend has to go into the answer. But here, because we're cutting off a 0 from the dividend and the divisor, we're doing both to the same side. We don't have to put that 0 on the end. So here's an example for us. 2,840 divided by 20. I know many students who would just throw up their hands and say, that's too big of numbers, I can't work with those numbers. But now you know the strategy. Take off the zeros and we end up with 284 divided by 2. And look at all these numbers here. Remember I told you, look at your numbers before you dive into working the problem. All of these are even numbers, so that makes it easy to use the mental math that we learned in our last lesson. So 200 divided by 2 will be 100. 80 divided by 2 will be 40. And 4 divided by 2 will be 2. And you can do that without even breaking out your division frame. No need for that in these questions. You do need to use that for some questions, and it will come in useful. But don't use it more than you have to. Use the strategies that you've learned to make your division questions easier. Let's look at these ones. Now here we have 2 zeros here and 1 0 here. Now here's something to note. You cannot take both of these zeros off because you only have 1 0 here. If you have only 1 0 in the divisor, you can only take 1 0 off of the dividend. So let's do that. So that gives us 60 divided by 2, it's 30. 800 divided by 40, again, only take 1 0 off because we only have 1 0 in the divisor. 80 divided by 4, we know that'll be 20. 360 divided by 90, again, many students, oh, those numbers are too big. But you know now, take off those zeros, and 36 divided by 9 is 4. And 42 divided by 7, when we take those zeros off, will be 6. Now that we've reviewed that, we can estimate quotients by rounding to the nearest 10. Now you can see how the things that we've learned at the beginning of the year were the foundation so that you can do more complicated questions and harder things at the end of the year. So make sure as we're going through, you're not forgetting about the things you've already learned because you need to put them in practice as we go on through this year and in your future math courses as well. So now if we're rounding to the nearest 10, for 817, remember our 10 is right here, so we need to look at the ones digit. Since the 7 is closer to 10 then to 0, we're going to round it up. So this becomes 820. And we're dividing that. We're not going to use 19. We're going to round it again to the nearest 10. We want to look at this number in the ones place. So 9 is closer to 10, so we round it up. So 19 is close to 20. Notice this sign here. This is the sign we use to mean approximately. That's what we write when it's an estimate. If we want an exact answer, we write the straight equal sign. But if we're approximating, we use the wavy equal sign to say it's almost or close to. So now, because we can do this exactly, we're going to use the exact equal sign. And we know we can take off the 0 here and take off a 0 here. Do 82 divided by 2. 8 divided by 2, or 80 divided by 2 would be 40. 2 divided by 2 is 1. So our estimate for this answer is 41. So here's another way that we can do estimating. We can round them to the first digit. So you might have heard of this before as front-end estimating. And when we do front-end estimating, we just take the first number, write it down, and every number that's behind it gets a 0. So this turns out to 800 divided by 10, because 1 is the first number there. And we just put a 0 at the end instead of the 9. Again, this will be an exact answer. 800 divided by 10, oh, we can take off one of those zeros. 80 divided by 1 will give us an answer of 80. Like I said down here, this is sometimes called front-end estimation. That's the same thing as rounding to the first digit. They're both referring to the same strategy. So let's compare what we found. When we rounded, we did this same equation twice. When we rounded to the nearest 10, we ended up with 41. When we did front-end estimation, we ended up with 80. Wow, those are really different, aren't they? When we actually divide 817 divided by 19, let's figure it out. 81 divided by 19, well, that's almost 20, so I'm going to say that that's probably 4. 19 times 4 is 36. 4 times 1 is 4, plus 3 is 7, so 76. Do our subtraction there, borrow, which makes it really messy in there, but that's okay. Bring down the 7. 57 divided by 19 will be how much? Let's try 3. 19 times 3. 3 times 9 is 27. 3 times 1 is 3, plus 2 more is 5. So that was right. 3 and 57. Subtract those, we get 0. So our actual answer is 43. So which method of estimation gives us a better result? And remember, a better result means it's closer to the actual answer. Rounding to the nearest 10 is a better method of estimation than front-end estimation. We really rarely use front-end estimation in real life, but it's good to know anyway. Here's a third strategy that we have. This one is called using compatible numbers. And compatible numbers are numbers that are close to the actual number, but they're easier to calculate with. And to do the calculation mentally, often we end up using multiples of 10. So here's our first example. Here we have 187 divided by 6. And we want to know approximately what the answer is. Remember, that's what this sign means. It's approximately. Our hint says what multiple of 10 is close to 187 and divisible by 6. Something that's close to 187 has a 0 at the end. That's what it means when it says multiple of 10. And we can divide it by 6. If you said 180, you're correct. 180 divided by 6, we know will be 30, because 18 divided by 6 is 3, and then we need to put that 0. There's no 0 here, so we can't eliminate it. So we need to put that 0 at the end over here. That's kind of a complicated thing, knowing if you need to put that 0 over or not. If you're confused about that, then do some practice, think it through, and if you're still not sure, then give me a message and we can work on that together, because I know that that's confusing. So this gives us an estimate of 30 as an answer for 187 divided by 6. That's going to be fairly close because we only took 7 things off. All right, here's another example. Marcel has asked some friends to help him sell tickets to the school play. He wants to divide 417 tickets as evenly as possible among 7 people so that they can each sell some. About how many tickets does each person get? Well, let's use this table to help us find out how many. If we took 7 times 10, it would equal 70. 7 times 20 would be 140. 7 times 30 would be 210. 7 times 40 would be 260. But wait, how far do we need to go up on this chart? Do we need to fill the whole thing in? Right, we have to go up to 417. So if we hit 417, then we can stop, right? 5 times 7, 350. 6 times 7, 420. 7 times 7, 490. Oh, hang on a minute. Did we get as far as 417? Yes, we did, right here. So, about how many tickets does each person get? Yes, each person will get about 60 tickets. Because we have 7 people, so that's our groups, right? 60 tickets for each person, or in each group, will equal 420, which is 3 more than he needs, right? So we can say 417 divided by 7 will approximately equal 60. So if he gives each person 60 tickets, someone will get a little bit less, and that's okay. On this one, it asks us to estimate using compatible numbers. So we're doing the same thing. And whenever we're using compatible numbers, here's your hint. Make a table of the divisors times multiples of 10. So remember, the divisor is the second number. So that's why we have 6 in our table here. So 6 times 10, 60. 6 times 20, 120. 6 times 30, 180. 6 times 40, 240. 6 times 5, 300. 6 times 6, 360. 6 times 7, 420. 6 times 8, or 80, is 480. And 6 times 9 is 560. If you can't think of those as quickly in your head, remember, just practice your multiplication tables and they'll come. The more you practice, the better you'll get at them. So looking at this, we want to find the number 379. We probably won't find it exactly on this chart, but we should be able to get fairly close. So 379, that's close to 380. Do we have 380 on here? We don't, but we do have 360. So we could say that 379 divided by 6 is approximately, or is close to, 60. What about this one? Here we're dividing by 6 again. 6 is our divisor. 408 divided by 6 will be approximately what? Let's see where we have 400. This is the closest number that we have, I think, right? So 408 divided by 6 will be approximately 70. Sometimes your estimates will be really close when you use compatible numbers, and sometimes they'll be quite far away. It really depends on how close the dividend is to any of the multiples of the number that you're multiplying. Okay, it is useful to estimate before you calculate an exact answer to help you recognize an incorrect calculation. So we want to make sure that we get the right answers before we submit our work, right? So that's where estimating can help you in math. Here, Kim divided 345 by 7 and got the answer 65. Does this answer seem reasonable? Let's use the chart like we used in the last 2 questions to figure it out. So we're going to multiply by 7, and we're going to multiply 7 times 10, 20, 30, 40, 50, 60, 70, just to see if this makes sense. 7 times 10 will be 70. 7 times 20 will be 140. 7 times 3 will be 210. 7 times 4 will be 280. 7 times 5 will be 350. 7 times 6 will be 420. And 7 times 7 will be 490. So let's look where 345 falls in our answers here. It would be right about here, because we can see that 7 times 50 would be 350, and 350 is more than 345. So looking at it again, does Kim's answer of 65 seem reasonable? Her answer would fit right in the middle of here. Now we can see, no, she made a mistake somewhere, and her answer should be something just under 50. That's how it's useful to use estimation before calculating the exact answer. And that's part of what I mean when I say analyze the question to know what you need to do first before you try to solve it. Estimating can also help us in the grocery store. So for this one, a 24-pack of super bottled water costs $82. A 12-pack of very best bottled water costs $48. All the bottles contain the same amount of water. Estimate the price for one bottle of each. So how are we going to estimate the price for one bottle of each? And then find which is the better price. That's the question that we have, right? How do we know which one to buy? How do we know which one is the better price? And our hint here says use rounding to the nearest 10. If a 24-pack costs $82, our actual question will be $82 divided by 24 will give us the price per bottle. Same with this one. 48 divided by 12 will equal the price per bottle. So taking 82 divided by 24, those are big numbers. I'd rather round it to the nearest 10 to figure them out. So 82 to the nearest 10 would be 80, and 24 to the nearest 10 would be 20. Oh look, we can cross off the zeros here because they're both on the same side, giving us 8 divided by 2, and that's 4. So each bottle of water in this pack will be approximately $4. What about the other pack? If we've got 48, the closest 10 will be 50, because we'll round it up to 50. And we're going to divide it by the closest 10 to 12 will be 10. And again, we've got zeros on the end, so we can take those off. 5 divided by 1 will be 5. So 48 divided by 12 will be approximately $5. So to the answer, which one is the better price? It's the 24-pack. So that's a couple of examples of how we can use estimation to help us in our real life and in our math work. And with that, you've got page 88 to finish in your practice book. If you have any questions about it, if you're unsure about how estimation works, I know it's a difficult concept for some students, and that's okay. That's what I'm here for, to help you. So if you need any clarification, just make sure that you contact me and ask for it, and I'll be happy to help you with it.